Testing. Testing. Okay, let's see here. I'm going to do this live. I usually do this off camera. I'm basically going to edit this schematic from, I'm going to what's the word? Freelance this one. This is the first time I'm attempting to do this. I'm basically going to incorporate my double pole switch method to, hold on a second. Let's see here. So these two, this battery is the source. Don't pay attention to the way these two banks are put together. One is for fast charging. I guess he didn't know how to spell rapid. Maybe that is how you spell it. I don't know. I thought it was RAPID. But anyway, no offense to the creator. Just I am very semantic. So this is just, forget about this. Think of this as the source, okay? This being your positive, and that being your, and this being your negative. So your positive will go through, I guess this is a light filament in here. I'm not sure what it is. And go through there, through the diode, through the battery bank to charge it, and out this diode back to the negative. Back to the negative this way. Okay, through this battery bank. Very interesting. Auto swapping battery circuit. Maybe this is already powered by, maybe this is already auto swapping. I don't know. I mean, let me take a look at this.
Repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor.
Oh, no, 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 no.
So let's see what we got here. Testing 1, 2. Make sure I'm not too loud.
Hand-me-down shoes, but my vision brand new. Whole block yelling when the sirens move through. I swore to my brother, this ain't all we gon' do. Now we talking fast stacks. Rubber bands tight, came up from the back steps. Now the view bright. Used to pray for $1 for the bus ride.
Testing 1, 2.
Feel back city in my real chrome. Yeah, we got fast stacks, but the scars still speak. Every bill in my hand got a long, long week. I remember every night, every cold street light. Turn that pressure into joy when the plane took flight. Put up on the corner where we used to skip class. Kids on the same curve, chasing what we never had.
And how's the audio now?
Switch ain't just a rollie, it's the game you surpass. Listen, mama at the window, new smile on her face. No more pictures.
All right, we're good. So, what do we got here?
Now we talking fast stacks. Rubber bands tight, came up from the back steps. Now the view bright. Used to pray for $1 for the bus ride home. Now the roof peeled back, city in my real.
So ultimately, this is the, okay, it says this is the feeding battery.
Top to the midnight stars, from the shoebox cash to the foreign cars. I still feel that block when I grip this wheel. Every laugh, every loss, that's the part that's real.
So positive feeds this way. And it goes through the bucking coil, out the bucking coil, through the battery bank, the charging battery, back out here to the positive. It does nothing, but it also goes, the positive also goes this way. Let me change the color here. Positive from the battery source takes an alternate route through here. To the rapid charging. Positive through the out to the negative of the source, and that's how the loop is completed. So what goes on here? The source battery is going to ultimately, it looks like it will, die out. And they have these 3 battery banks hooked up in such a way to extend the life of something, I don't know, of the power supply. So this source battery doesn't look like it's getting recharged in any way, shape, or form. And you currently do have to swap these 2 banks. You will have to swap them, according to what I see now. So, then that means I will continue and incorporate my double pole Bedini modification of the SG circuit to work with this circuit. And I will take it, I will leave this source here, and I will delete this and this, and put in the circuit in place. All right, let's do that. Okay, so let's try something here. Let's delete this. Let's delete this. We don't need this anymore. Over Unity battery charger. All right, now we're going to put in the double pole switching. This may take some time. How do I do this? Single battery. Alright, let me. I already know the positive goes in there, and the negative comes out here from the source. So let me get rid of this. All right. Positive down to negative. All right, and he had the charging battery there. Okay. Let me see here.
was übrig ist. Ich tanze, ich bin nicht ich.
Let me use this as my reference. Okay, we got two diodes. I see the source, positive.
Street lights hum like a lullaby. Your shadow dances caught my eye. The city's heartbeat, a quiet sigh.
All right.
Every step echoes, every breath stays. The night holds secrets in velvet waves. Oh, midnight.
So we're gonna put a battery down here. We will go with red on the right side, black, or let's just go with green for negative on the left side. So we know positive goes in here. Goes this way and that way through the source battery. Because there's only going to be one battery now, top left. Positive goes in there.
Erinnerung, sie kommen nicht linear. Sie kreisen wie Licht unter geschlossenen Lidern. Ich sehe Fragmente, kein Anfang.
Positive goes in.
Deine Stimme im Rauschen. Verloren im Moment. Zeit fällt in Schleifen. Sekunden aus Glas. Ich greife nach
If
gestern.
I am not paying attention to the
Doch
chat,
es bleibt nur ein Abdruck.
I apologize.
Zu nah.
Oh, hey, what's up, Bernie? Just doing a little modification of a circuit I found, which needed a self-swapping battery circuit. Okay, so the positive goes in from the source. That's the source. Goes through the filament here in the center. Okay, hold on. Let me go over this again. So positive from the source goes through this filament in the center, whatever that is. I think it's a light bulb or something, or a resistive load. Looks like a incandescent. I don't know what it is. And then it goes through this diode. But what really happens is the positive has to go through the coil to charge the bucking coil in this fashion, counterclockwise, clockwise, rotating back to the negative of the source right here, which would be that single battery at the bottom. And I don't know if those diodes are necessary or not. We'll find out. So positive goes through there, through the coil, out to the negative of the battery. Sprechen Sie Deutsch?
Was bleibt, wenn der Sound verklingt? Erinnerung.
Das ist gut. Kaltes Wasser, tanken. Gute Nacht. So, there you go. And what was that other path that was going? Right, that's correct. So we got that. What was those diodes things? Well, those diodes were just, yeah. Okay. I don't know why that going back to the positive, I guess. I'm winging this one, folks. It's gonna take some time. All right. That is correct. May not look like it to some of you guys, but Give it a chance. Take this out. All right, that is basically how it goes. Now I have to put the double switching in. Let me take this out here. Okay. From the looks of it, it's very similar to the one up top left there. Now it's time to put this double pull switching in. Let's start with the positive on the source. We have two legs, one going to the diode, another going to the coil. Huh, so similar to the one up top left there. Two legs, and the one going to the coil, the switch is going to the coil part. Okay. So the switch goes here. Heading to the coil. And the other on the switch on the negative. Is on the leg. Heading to the other side of the coil. So that positive switch and that means when it goes through. Let me do a little tracing here. So when this positive goes through this filament and then through the coil to the negative, that's how it charges. And then because you're putting a positive on this side of the coil and the negative from here on the side of the coil, that would be the polarity of the coil when it's charged by the source. And then the flyback would be like so, negative here and positive here. So that means the flyback is this requires 2 more diodes. So, oh, wait a minute, I got this. Yeah, that's right. All right, let me do this again. Positive leaves the battery, goes through the filament to this side of the coil. It goes through the coil out to negative, leaving negative here, positive there. Then the flyback happens in reverse polarity, negative there, positive here on the coil. And Okay. Okay. So the flyback is here. Okay. Flyback has to come out here. That would be the positive flyback. And you add a diode so you don't feed the battery when you don't want to. That would be your high voltage diode.
Dein Rücken warm, Salz auf der Haut. Ich schmeck nichts mehr auf deiner Haut. Dein Atem flach, die Luft so schwer. Wir atmen ein, wir atmen mehr. Salzige Haut, ich geh in dir verloren. Salzige Haut, wir tauchen immer tiefer. Salzige Haut, bis wir kein Ende spüren. Salzige Haut.
All right. So now let's double check this. Positive goes through here. Hold on. Well, right, that doesn't matter, right. So I was just concerned about this, you know, when the positive goes through here, through the coil, back through, you know, this diode to positive. Well, it doesn't mean anything. So, but meanwhile, the coil got charged because the positive can flow through the coil to the has to be able to flow to the negative, so I have to find a way to do that. So that positive comes out there. Okay. So that's what I can do. This diode, I can go. This diode can go. I don't know what it's doing there. Oh, yeah, it's blocking. Okay, so positive goes to here. Let me open up the... Keep this for a reference.
Alles warm und trotzdem fett ausbleibt. Frost unter der Haut. Tief in mir.
What was going on before was source battery up here. Source battery. Let me just refresh my memory here. Source battery was coming out positive, going this way. I made a mistake here. So it was going, I forgot what was going on here. So source positive was going through the coil out this way through the coil to source negative, which is passing through this battery to here. So I had messed up here. Source positive is actually right there. So that's source positive. Right there is source positive coming in. So I kind of messed up here. So source positive can now go in here. Through the coil, through the filament, out to source negative, which is that. I'm just gonna, now that I got the source positive right, just gonna put the circuit in it. Patience, folks, this will be correct. I guarantee you that. So Source positive goes through the coil. Clockwise, counterclockwise. Exit the coil through a filament to source negative. Mission accomplished there. Okay. This diode may or may not be necessary. Let's take it out for now. Okay. Dun, 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 dun. Dun, 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 dun. So it's double pole switching time. So on the positive of the source, we have that the switch leading with its own leg directly to the coil. So that can be right here. So that's the one switch. And the flyback diode going to the positive of the source is on the other end of that coil. So and here we put the diode. Tomorrow night I'll probably animate the switching and post that. Okay. And then the other switch is on the negative. Top left is the reference. On the negative with its own leg to the negative side of the battery. Yeah, to the negative side of the battery and the negative side of the coil. Now again, let's review this. Positive exits the battery, goes through the coil, clockwise, then counterclockwise, out the coil, through the filament in the center there, back to negative. And the switch on the negative is right at the negative of the battery. So So this takes brain power, folks. So negative of the battery, you put the switch and yeah, okay. So let me jot this down. Let me just put the switch first. Yeah, put it right here. So that's the other. This is double pole switching. So both those switches move together when they're both closed. We have ignition on the coil, and when they're both open, we have flyback coming back to the coil, to the battery, sorry, from the coil. And this is your positive from the battery source, and this is your negative. So the flyback will be inverted plus here. And that plus flyback will go right through here into the battery. And this negative flyback here has to, okay, so now here we have it. Almost done, folks. We gotta run this channel here. This is cool. I'm really glad I thought of this double pole method for returning the flyback to a single source. This makes things a lot easier. Less complicated. The way I like it. So, yeah, and then it comes down here. And the negative flyback. Now, so because, let me explain this because it's important. When you switch these two switches to close, you're going to have you can have positive going through here, through the coil. Sorry, it's going to go this way. And it's going to go through the coil, right? Out the coil, over to negative when the switches are closed. Now the positive can also go this way and short out to the negative of the battery, and just you'd be wasting power, and the coil will not do anything, will not ignite. So that's why you have the flyback diode there. Okay, and that flyback diode is a negative flyback, so that's why you put a diode here to block the positive from the source. You want to block the source positive from hitting source negative when the switches are closed. But this diode will not block the flyback because the flyback is inverted in its polarity. Okay, I think that completes it. But let me just draw the positive from the source right here. And in red. Let me remove this. And that would be the, let me remove that. So this positive from the source lands right here. Make it real small. Plus from the source. 1 second. Be right back. 1 minute. Okay. So your positive from the source lands right there on the right side of the coil. And your positive flyback I will put in a plus with a circle around it. And that's your flyback positive. And then we'll do the source negative. Which is right there. So it goes through the coil. Yeah, so your source negative is right here. Okay. I'll dash the path for the negative. Okay. And your flyback negative will be where the positive of this source positive was. And the flyback negative and circled and positive circled happens when the switches are open. When the switches are closed, the forward polarity plus and minus is shown on the coil where it hits the coil. And it's those polarities are not circled. So now I will show how this works. I will trace it out. So when the switch is closed, source positive goes through the coil, out the coil. Okay, in two paths. One path is through here, back to source positive, which does nothing. So you don't have to worry about that. The other path, and it's the same thing in the Bedini circuit. This does the same thing there. The other, so the source positive goes through this filament after it passes through the coil, which is very interesting. And then to the negative. And that's how the coil is charged, and the filament as well. This is interesting. So that's that. So that's when the switches are closed, that's the event. Now the switches are, now you can see there's no conflicts here. Okay, I'll show you how there's no conflict. See, the plus has to go that way. It gets blocked this way. The diode blocks it. These are high voltage diodes. And the negative, it cannot go through here either. It's, blocked by that diode. So now let's look at the flyback. Encircled, the red plus flyback circled and the negative circled on the right side. So red on the left side circled flyback. Where does it go? It goes down this way to the source battery. Now, for that source battery to receive that plus flyback, that plus flyback has to make it to the negative of the flyback. And it goes this way through this diode to the negative of the flyback. And there you have it. So the battery is getting recharged by the flyback here. And the flyback doesn't appear to be going through the filament either. The battery seems to be the load on the flyback. Let's make sure that the filament inside here is not receiving flyback. So would the flyback go this way? Plus flyback, does it have anywhere to go? Remember, the switches are open when the flyback happens. Nowhere to go. Nowhere to go. The flyback has nowhere to go. So it doesn't go through the filament. There you have it. All right. It goes through the battery. There. Voila. As they say in France. Yeah. So that's that. I'm going to leave this as it is and consolidate this. It's official. This is done deal. Let me just put 12 volts there in the battery, and I don't know if anybody's watching, but I'll open it up for chat if you guys want. Let me do that. Hold on. Where's that? Okay, yeah, I'm gonna post a link for if anybody wants to join. It's a little late, but sorry, I had to get this done first. So let me finish this with the 12 volts. Put in 12 right here. 12 volts. Okay, 12 volts. What is this thing? Oh. And that would be that. There's that. There you go. 12 volts DC battery. There you go. So that's that. Let me trace it one more time. Confirm everything. I'll trace it in red So plus comes out the battery here. You close the double pole switching here first. Let me type that in there. Where is this? Okay. Okay, so switches are going to close together. Oops. Go back to that. These two switches close together. Positive leaves the battery. Let me add that also. Oops. What is that? Okay, plus minus with circle is flyback. Okay, so positive leaves the battery when both switches are closed. Can't go that way, it's blocked. Can't go this way, it's blocked. But it can go through the coil and out the coil. It can go to its own positive, which does nothing, has no effect. But it's, you know, what the effect is when it goes through this filament in the center here out to the negative. And that's how the coil gets ignition, when the switches are closed. Oh man. Hold on. So, give me a second. Okay, now when the switches are open, the flyback polarities with the circle around them, plus and minus, plus flyback can go this way, but it dead ends right here because remember the switch is open at this time. So instead it goes this way to the battery, through the battery, up the negative, through this diode to the negative of the flyback, and that's how the flyback charges the source battery. We are good to go here, folks. Yeah, enjoy this circuit. George, I don't know how you pronounce his name. Give me a second here. I'm going to post a link to where I found this circuit from George something. Hold on. Or what's that? Okay, over here. George Chaniotakis. You know, I don't think this is his circuit. I mean, but he's promoting the idea. This is a bucking coil circuit. It looks like it's been around, but he promoted the idea, and maybe he put in that battery system, which you would have to swap. So now you don't have to swap anything. George, if you're out there, take a look at this. That's his name. And the link is, I'll put it here too. The link to the video where I got this circuit on his channel. Put it right below. That's the link to the video where I got this circuit. And this is the modification from a where is it? Let me export this before I lose it. All right. So the circuit that this is the circuit that I modified right here. Took out all these batteries. Now it's just one battery with the, you know, like so. And it's double pole switching. And here, I don't see any switch. I don't see any switch. That's the only thing. I don't know if it's constant current. I don't think so. I think maybe he just forgot to put a switch in there. Because if this is constant current, maybe the filament is maybe that's a reed switch in there. Maybe that's what that is. I don't know what that is. If that's a reed switch. I don't know. Maybe this is a reed switch in here, in the center there. Which would, I don't know how that would work, but you can, you know, if you want to double pole switch this with a single battery, so you don't have to swap any batteries. Then you would, maybe that's a resistive load. which would probably cause a switching effect with that magnet bar there. So you can just replace that thing in the center with a straight piece of metal or even a light. I mean, you can keep the magnet bar as well. I mean, whatever's in there, whatever that is. I think it's a light, a resistive load. Because these source batteries are 1.5 volts times 6, so 9 volts. What is that? 1, 2, 3, and then 6, and then 1, 2, 3. 9 volts. Whatever, maybe that's a 9 volt. Whatever it is. Yeah, so this is what I'm gonna do. And whatever that is in the middle there, a 9 volt. Well, it would have to be a 12 volt something now, because what was his charge battery? His charge battery was 1, 2, 3, 4 times 4, 6 volts. From a 9 to a 6 volt. I would just go ahead and keep that thing in the center of the bucking coil a light, a resistive load, a 12 volt device, and you can switch it with double pole switching and still do your experiment. Okay, if anybody wants to join, looks like a hot dog in there, like a warmer. What's up, John Gray? You know what that is in there? I think it's a resistive load, like a light of some kind. Because, you know, I don't see any switch in his device. Nonetheless, you could still charge or still run this circuit with double pole switching. What happened to where's my oh, there it is. You can still run this circuit with the double pole switching. Yeah. You don't know? Okay. I'm gonna assume it's a light, because it says plasma generator. Maybe it's an incandescent bulb, which with a magnet there and the coil being EMF'd might cause a switching effect. And you can possibly use that EMF well, not possibly, you can use that EMF to trigger these double pole switches at whatever rate the plasma light is fluxing. And how would you do that? Well, this magnet bar here would have to push a piece of metal, you know, with two contacts on it. So it would push the metal up, and then when the coil's ignited, it might cancel the magnet on the bar or something like that, and then so when it pushes it up, it hits these two contacts, and they run over this switch and that switch, and then it would come back down and disconnect. Ultimately, I'm going to control these two double pole switches the same way with EMF. I plan on doing it that way anyway. I don't plan on using a timer or transistors. I plan on using a custom-made contact relay that's influenced by the EMF off the driving coil. So when the coil is ignited, the initial position of the contacts of the two switches would be in the closed position, and this circuit would turn on as soon as you connect your battery. As soon as you connect the battery to the circuit, it turns on, and as it turns on, it will be closed initially from default, and then you connect the battery with a separate switch, and then the switches will open out of their default state, like so, open, and they'll do that because the coil will get EMF and push these switches open with the mechanism using magnets and relay contacts. So that's my concept for that. It's always been that way. I mean, not always, but that's where I landed on this double pole switching goal, is to control the double pole switches with custom-made contacts influenced by the EMF of the coil. At first ignition of the coil, the EMF would open up the default position of the two switches to open, thereby de-energizing the coil, allowing the magnets, because this contact will have magnets bringing the switches back to their default position of closed, at which point the coil gets energized again and opens them, and the process keeps repeating. That's my idea for doing this. It's common. Well, I understand it's a very old school method, and I like it, that method, because you don't have to waste power on a signal generator. And the smaller you make these contacts, the closer you can put them together, and the faster you can switch on and off. And the faster you can switch on and off, the less of a magnetic field you're going to generate in the coil. You don't want to generate a whole lot of magnetic field, because then you're wasting power. And if you do generate that magnetic field, you want to use it to spin the wheel so you don't waste the magnetic field. That's only necessary, the wheel's only necessary if you can't switch fast enough. So my goal is to build a contact, double pole contact, influenced by a magnetic field, and controlled to return back to its default position by magnets that are part of the contact. Let me turn this down. So, yeah. I guess I'll leave it there for the night. Unless anybody wants to join and talk about this circuit here. Hope you guys enjoyed that. Oh, it is a light, right, John? Yeah, I concur. I agree with you. I think it's a light also. All right. Let me make sure I got this exported. Back it up. All right, good to go. I'm glad I did this. It was on my mind. Let's see here. All right, guys. Glad, thanks for watching. And see you next time.
Come on. Come on. Do it. 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 Who is doing it? Do it. Do it. All of it. Do it. Come on. Do it now. And I would do the rest.
Charge it into the battery, and then you want to repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source.